In Python, you can customize what happens when you ask your objects whether they're equal to other objects. We have 2 point objects here, that is, 2 instances of the point class. If we ask these 2 objects whether they're equal, Python tells us false, even though they have the same attributes. But if we ask one object whether it's equal to itself, Python tells us true, because the default implementation for equality in Python does the same thing as identity. We're really asking, are these 2 objects exactly the same object in memory? Now, we can customize what happens when we ask 2 objects whether they're equal if we understand how the equals equals operator works in Python. When the equals equals operator is used between 2 objects, Python goes to the first object and calls its dunderEQ method, passing in the second object. If it gets back true or false, it returns true or false. It gives us true or false back to that comparison. But if it gets not implemented, it then goes to the second object and asks whether it's equal to the first object. If it gets true or false, again, it gives us true or false back. But if it gets not implemented, it returns false at that point because neither of these 2 objects know how to compare themselves to the other object. So if we wanted to implement equality on this point class, if we wanted to customize what it means for point objects to be equal to other objects, we could make a dunderEQ method. Our dunderEQ method needs to accept self and some other object. And we're going to return self.x and self.y. We're going to take that tuple and compare it to the same tuple on other.x and other.y. So if our x and y attributes are equal to the other object's x and y attributes, then we're equal. So if we take 2 point objects that have the same x and y values and we ask whether they're equal, we'll get true now. But if we compare 2 point objects that don't have the same x and y values, we'll get false. But we're not done yet, because our dunderEQ method right now is not very well behaved. If we pass in an object that isn't a point, something weird happens. If we passed in a number or none, for example, we would get an attribute error. We get an attribute error because that other type of object doesn't have an x or a y attribute. So there's a number of ways to solve this problem, but the recommended way is actually to rely on type checking to say if other is an instance of our point class, we'll compare it as we were before. But if it's not, we return not implemented. Now this might seem a little bit weird because it's uncommon to see type checking used in Python. We usually practice duck typing instead. But this is one of the few places in Python, inside of dunder methods, where type checking is deemed acceptable. Because we really need to ask ourselves, do we know how to compare ourselves to that other object? And if we don't, we should go delegate to that other object instead. So now if we compare our point object to none, we get false as expected. If you'd like to customize what it means for instances of your class to be equal to some other object, you can define a dunderEQ method, but make sure that that dunderEQ method returns not implemented if given an object that you don't know how to compare yourself to.